Good afternoon, advanced algebra students. I hope you are having a fantastic day. We are starting our notes for chapter 5. So if you can get something to write with and a piece of paper, that would be fantastic. And again, please remember to feel free to pause anytime you need to during this video. Our first lesson in chapter 5, section 5.1 is nth roots, radicals, and rational exponents. And basically, in chapter 4, we looked at various aspects of rational functions. In this chapter, we're going to build on that by learning how to interpret rational exponents. And remember, rational is just a fancy way of saying fractions. So what we're basically saying is exponents in fraction form. So we're going to include it in this. We're going to be looking at what we call nth roots and radicals. So before we kind of dive into the main point of the lesson, I just wanted to review what it means to take the square root of something. So if I look at, for example, the square root of 49, 49 is 7 times 7. And when I ask you what the square root of 49 is, you're asking yourself, what number do I multiply by itself to make 49? And of course, the answer is 7. But what I want you to see visually here is that because I had a pair of 7s, I can take that pair out and my answer is just 7. We can use this concept to also take a look at different kinds of roots. So for example, the cubed root of 125. 125 is 5 times 5 times 5. So since I'm looking for a cubed root, I'm looking for groups of 3. So the answer to this problem is just going to be 5. I can also, for example, number 3, look at the fourth root of 256. 256 is the same as 4 times 4 times 4 times 4. And because this is a fourth root, I'm looking for groups of 4, and I would take this out to get 4. Now, I'll have to be honest with you. The book, for whatever reason, this book and no other book I've ever taught out of, asks us to say that the answer to this problem is positive or negative 7, and that the answer to this one is positive or negative 4. However, traditionally, in the way that we normally work with advanced algebra, the only time that we include this positive or negative is if we're solving an equation and we use the square root symbol in the process of solving that equation. So for example, if somebody asks me what is the square root of 49, I am just going to say 7. However, if they say x squared is 49, what is the square root? And I add a square root symbol to the original problem, then I would say positive or negative 7, because either one squared equals 49. So if you add the square root to the problem, then you must add a plus or minus for any even root problem. If you don't add the square root to the problem, then you do not need to. So let's go ahead and look at now how to simplify problems with rational exponents. So I want to clarify that if I have this kind of a problem here, and the way I would read that is x to the power of m taken to the nth root, or I could say the nth root of x to the power of m. The important thing is to notice that this is equivalent to 3 different things. It is equivalent to x to the power of m over n. Notice that the power goes in the top and the root goes in the bottom of the fraction. This is also equivalent to x to the 1 over n power, all taken to the nth power, or x to the power of m taken to the 1 over n power. Now, the reason why these last two work is if we put a little 1 underneath the m and we multiply across the top and bottom, which we do when we're taking a power of a power, we would get m over n. So let's do a few examples along those lines. Example number 4 is going to be the fourth root of 25 squared. So my power is the 2, that goes in the top of the fraction. My root is the 4, that goes into the bottom. This is 25 to the 1/2 root, which is the same thing as the square root of 25, because it's 25 to the power of 1 taken to the 2nd root. So this would just be 5. On example number 5, let's just put this in a different format. We don't necessarily have to solve it, I suppose. Let's do the 5th root of 243. We can think of that as 243 to the power of 1 taken to the 5th root. So this would be equivalent to 243 to the 1/5. All right, why don't you try number 6 yourself? We're going to take the 7th root of y squared. Can you write that in rational exponent form? And see if your answer is the same as mine in just a minute. Okay, so this would be equivalent to y to the 2/7 power. All right, let's do several more examples. Example number 7. Let's do the 4th root of 49 squared. This is going to be 49 to the 2/4, or 49 to the 1/2, which is the same thing as the square root of 49. The reason is, again, because there's like an invisible 1 here and an invisible 2 there. So the answer to this would just be 7. Let's go ahead and look at number 8, example number 8. The opposite of the cube root of 64 to the 5th. So this is going to be the opposite of. Now, when I am working with this and I'm trying to simplify it, it is typically easiest to write something when we're putting it from radical form to rational form. This format here is usually the easiest one to work with. The reason is because it allows you to reduce your numbers and make them smaller at the beginning. So for example, instead of taking 64 to the power of 5, which would take forever to work out on my paper, I can take 64 to the power of 1/3, or the cube root of 64 first. The cube root of 64 is asking me what number would I multiply 3 times to make 64? And the answer is 4. So now I have a much more manageable problem. I'm taking the opposite of 4 to the power of 5, which is negative 1024. Again, I would do the exponent first then, and then multiply by -1. All right, let's do example 9, and then we'll go on to a little bit of a new kind of problem. Let's take 32 to the power of 4, all taken to the 5th root. Can you take a moment and see if you can write that in fraction form? How would you write that in fraction form? That would be 32 to the 4/5. Let's see, where is it? This format right here. Now I'm going to translate it to this format here. I'm going to do 32 to the 1/5 first and take that to the 4th power. 32 to the 1/5 is 2. And then when I take 2 to the power of 4, I get 16. All right, so we've learned basically how to switch things back and forth between radical form and rational exponent form. Let's go ahead and do some with variables on the inside. All of these had just numbers on the inside, and so I'd like to show you a few examples that have letters and numbers so that you can be prepared for all eventualities. Let's take a look at simplifying this expression. So this will be example number 10. Let's say I've got the cube root of 8y to the 12. Now for me personally, I just have to be honest with you, I'm a super visual learner. So even though I teach math, I like to write this out. I write 8 as 2 times 2 times 2, And it only takes a second to write down 12 y's. So I've got 4, 5, 6, 7, 8, 9, 10. I've got 12 y's. Now, because this is a cube root, I'm looking for groups of 3. So I can just circle the groups of 3. Every time I have a group of 3, it means I can take that number or letter outside my radical symbol. In this case, there would be nothing left inside. I would have 1, 2, and then I would have 4 y's. So this would be 2y to the power of 4. All right, let's go ahead and do the 4th root of x to the 16th and y to the 8th. In this case, again, it can be helpful to write out the 16 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then the 8 y's, 1, 2, 3, 4, 5, 6, 7, 8. And then because this is a 4th root, I am looking for groups of 4. So let's see how many groups of 4 I have with the x's. It looks like I have 4 x's and 2 y's that I can bring down. So this is going to be x to the 4 y squared. All right, let's go ahead and talk about how we can use nth roots to solve equations. So the basic steps are going to be to isolate our variable and then raise both sides of the equation to a power that will make the exponent of the variable become 1 and then solve. So let's see here. I think this will be example number 12. We're doing a lot of examples here just because none of them really take that long. If I have 2x to the 5th equals 64, again, I want to isolate the variable first. So I divide both sides by 2, and that gives me x to the 5th equals 32. Now that's basically asking me what the next step would be to raise both sides to the 1/5 power. The reason is that makes the variable on the x become 1. So now I know I'm just basically looking for the 5th root of 32. And that is asking me what number would I multiply 5 times to make 32? And the answer would be 2. Okay, let's do another one here. Let's do 2p to the 4th equals 162. So I believe this is example 13. 2p to the 4th is 162. So I would divide both sides by 2. I would have p to the 4 equals 81. Then I'm going to raise both sides to the 1/4 power. Now, in this case, because I am adding a radical sign to the problem, if you look at this, this is asking me to find the 4th root of 81. Because I am adding a radical to the problem, and because it is an even root, I do need to add a plus or minus this time for sure. So this is going to become p equals positive or negative 3. All right, let's just do one last problem, problem number 14. For this particular problem, it's going to be a word problem, and I'm just going to read it to you, and then you don't have to write down the words, you're just going to write down the math that I do. So it says here that a cubed-shaped container has an edge length that is 2 centimeters longer than the edge length of another cube. The volume of the larger cube is 729 centimeters cubed. When the water in the larger cube is poured into the smaller cube, how much water will spill? So basically, they're telling us that there's 2 cubes And then there's a small cube and a larger cube. And they're wanting to know if they pour out the contents of the larger cube into the smaller cube, how much will spill, which basically means they're just asking what's the difference in the volume between the two different cubes. So let's go ahead and get started here. Let's let X equal the length of a side of the smaller cube. And then we'll have X plus 2 be the length of a side of the larger cube. And we are told that the volume of the larger cube is 729. So I know if I have a cube that the volume is side cubed. It's length times width times height, but because the length, width, and height of a cube are all the same, it is just side cubed. So for the larger container, that side is X plus 2. X plus 2 cubed, and I know that volume is 729. So the volume is 729. Now, to solve this, what I would need to do is take both sides to the 1/3 power. What that does is make the left-hand side X plus 2, and on the right, I'm taking the cubed root of 729. Now, 729 is 9 multiplied by 3 times. So since I'm looking for a group of 3, I know that X plus 2 is 9, and then when I subtract, I get that X is 7. So we already know that the volume of the larger cube is 729. Let's write that down. Volume of larger cube is 729. Let's figure out what the volume of the smaller cube would be. If the length of the side is just, now we're going to write here 7, it would be 7 to the power of 3, which is 343. So the difference in the volumes, would be 729 minus 343, which would be 386. And this is in cubic centimeters. So that would be the amount of water that would spill. All right, that's it, guys. Good job. Thanks so much.